All right, our next topic is significant figures, otherwise known as sig figs. And what they do is they reflect precision of our measurements. So in science, we're always measuring things, right? We're measuring outcomes. How much product did you get? How much stuff did you put in? How many times is it better? That kind of thing. And whenever you're doing measurements in the real world, you're not going to have perfect precision. So no real world measurement is exact. There's always going to be some error in it or some kind of guesswork essentially in it. And that depends on the instrument, mostly depends on the instrumentation that you have. If you have better tools, you can get more precision and you get a more precise answer. If you have, cheaper tools that aren't as precise, you're not going to get as precise of an answer. So for example, let's take a block. So this is just going to be some kind of block. And we're going to want to measure the height of the block. And then over here, we've got our ruler that we're going to use to measure our block. And so we're going to call this mark right here. I'm just going to put 4 marks by it. Call this 1 meter, 2 meters, and then 3 meters. Meters are just a unit of measurement. Same like a foot, essentially. If you're not sure what a meter is. Anyway, so we're going to try to measure how tall this block is. So what we're going to do is we already lined up our ruler. So now we just need to line up this top to our ruler. And so let's think about what we know and what we don't know. So let's think about what we know. Well, we see that the block is greater than 1 meter, right? It's beyond the 1 meter mark. And then we also see that the block is not quite 2 meters. So it's less than 2 meters, right? So we know it's more than 1 and we know it's less than 2. So we know that our block is going to be at least 1 meter, but it'll be 1 point something, right? We don't know what the next number is, right? We don't know, is it 1.5, 1 2/3, whatever, right? And so what we do is we guesstimate, right? You look over there and you think about, what does that look like? Well, it looks like it's closer to the 2 than it is the 1. So I'm going to call this 1.7. And so that's what I would take my measurement as. This first number is a certain digit. And we know that one is true, right? It's obviously greater than 1 meter and less than 2 meters. This next number is the uncertain digit. And the uncertain digit is the estimated number. Right, so that's what I estimated. I estimated as 1.7. Maybe you're watching this video and you think, oh, I think that looks more like 1.8, or maybe I think it looks more like 1.6, right? Who's reading the measurement, it's going to slightly change because that's the uncertain digit. It's just an estimate. And your uncertain digit is always your rightmost sig fig. We'll learn about what sig figs in our second, but it's always going to be your rightmost number, right? So for example, you would record this measurement as 1.7, 1.8, 1.6, something like that. If you recorded the measurement as 2, this thing is 2 meters, that's not going to be correct. Or even if you recorded it as, 1 meter, that's not a correct measurement, because what you're saying there is, I don't know if it's 1 meter, 2 meter, 3 meter, right? When you only write one number, that's your uncertain digit. And so we know more than that. If you were to write this measurement out as 1.70, that's also incorrect, because you're saying that you have more precision than you have. What you're saying here is, I know that this 7 is an exact number and I'm only guesstimating the 0, but that's not true. We're guesstimating the 7, right? So we don't know that much. So you're always allowed to guesstimate 1 digit. And so depending on the tool that you have, they're going to have different levels of precision. In science, we often refer to tools as instruments or instrumentation. So if you hear me use instrumentation, I'm just talking essentially like a tool, usually that does some kind of measurement. Anyway, so we've got two thermometers here. Let's check out how we're going to read these thermometers and see which one is more precise than the other. So let's go ahead and take a look at the one on the left here. And right, we can see our thermometer reading is right up here. So let's think about what we know. Well, we know that our temperature is greater than 21 degrees Celsius, right? And then we also know that it's less than 22 degrees Celsius, right? That's what you know. And then you're allowed to guesstimate one additional digit, right? So valid answers for this would be something like 21.8, 21.7, 21.6, right? They're all okay. You can see that it's above half. So you want to, go above half, but you only want to guesstimate one digit, right? So this last number here is your uncertain digit. And any of these responses would be okay for this measurement. And somebody who's a scientist and reading your measurements, they understand that this last number is guesstimated, right? So all of these are all okay. Let's take a look at the thermometer on the right then. So let's think about what we know and what we don't know. First off, we see that we have some markings in between 21 and 22, and there are 9 of them. So that means that we have 0.1 for each. So this one, for example, would be 21.1 at this marking, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then we reach 22. So think about what you know. Well, we know that it's above 21.6, right? There's the 0.6 right there. And then we also know that it's below 21.7, right? So that's stuff that we know, and then we're allowed to guesstimate one additional digit. So your final reading would be something like 21.68, right? Maybe you think it looks way closer to the 7 than the 6, right? But 21.67, 21.69, 21.66, any of them are acceptable because this last digit here is our uncertain digit. All the other digits we know for sure are correct. The last digit we are kind of guesstimating, right? We're taking an estimate of what it looks like. And again, the person reading this understands science, and so they understand that that last digit is not 100% accurate. And then, right, if you take a look at these two thermometers, they're actually at the same level. And you can see the one on the right has more decimal spots to it, right? It has a more precise measurement. So this is a more precise tool, right? It tells us the temperature to a more precise location, more decimals, essentially. All right, one more example here. In chemistry, we measure liquids a lot, quantities of liquids. I need 2 mLs, I need, a liter, whatever, that kind of thing. And so whenever you have liquids, especially water, they don't lie flat in a container. They make what's called a meniscus. So when we're reading the measurement of liquids, we always read to the bottom of the meniscus. Right, so if you had, some graduated cylinder and you put some water in there, it's going to form this kind of thing, right? A meniscus where it kind of climbs up the sides of the wall, and where you want to make your measurement is right at the bottom of the meniscus, right? So for example, right here is your measurement right there. And then we can think about what we know, what we don't know, right? So if you take a look at this one right here, this bottom marking is 20, which means this upper marking is 21. And then the marking above it is 22. So we know that we're greater than 21. We know that we're less than 22, and we're allowed to guesstimate one more digit. So maybe something like 21.6 milliliters, right? Again, this last digit is the uncertain digit.